Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Excuse me. Today's puzzle is called Unsquare Dance by Damo89. I never know how to pronounce it. I say Damo, I'm not sure which one. Anyway, here are the rules. Too long didn't read, or TLDR, is these. We have normal Sudoku rules, diagonal rules, arrow rules, Renban, entropic, modular, Nabner, parity lines, white crop key dots, and no negative constraint for the white crop key dots. What are all these rules? So if you know all these rules, those are all the rules that are involved. Let's go through each of them for those who don't know what the rules are. We have normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3x3 box. We have a diagonal, where the positive diagonal, marked with a blue line, contains a set of digits 1 to 9. Or another way of putting it is that you can place the digits 1 through 9 once each in every row, column, and 3x3 box, and the positive diagonal. Or it's that way, I guess. We have arrows, where digits on an arrow sum to the digit in the attached circle. So for example, if you have 2, 4, sure, and 1 there, then this must be 7, because these 3 digits must add up to the digit in the circle, and 2, 4, 1 adds up to 7. So that's an example of how the arrow works. We have a Renban, where the magenta Renban R line contains a set of the consecutive digits in any order. So you could have something like, say, 8, 5, 7, and 6, and this would be valid, because these form a set of consecutive digits. 5, 6, 7, 8. What you could not have, though, is something like 5, 6, 7, 9 here, because that's obviously not forming a consecutive set. So that's an example of how Renban's lines works. We have entropic lines, where it's E, where along the peach entropic line, a run of 3 cells contains 1 low digit, 1, 2, or 3, 1 medium digit, 4, 5, or 6, and 1 high digit, 7, 8, or 9. And that's for any run of 3 consecutive cells. So for these 3 cells, you have to have 1 each of 1 low, 1 medium, and 1 high. And for this set of 3 digits, you must have 1 medium, 1 low, and 1 high. And that's how entropic lines work. Same for the modular lines. Along the teal modular M lines, a run of 3 cells contain different remainders when divided by 3. That is 1 digit from 147, which is 1 mod 3, 1 from 258, which is 2 mod 3, and 1 from 369, which is 0 mod 3. So along this stretch of 3 cells, you have to have 1 from the set 1, 4, and 7, 1 from 2, 5, and 8, and 1 from 3, 6, and 9. Same with this set of 3 digits for the modular line. Let's give examples of the entropic line. We could have something like, I don't know, 6, 9, 2, and this would be 4. So that could be valid, because this set of 3 digits has 1 low digit, 2, 1 medium digit, 6, and 1 high digit, 9, and so does this set of 3 digits. We have a 2 for the low, 4 for the middle, and 9 for the high. So that's an example of how entropic lines work. For modular lines, you could have something like, I don't know, 4, 8, 9, and 1. So this could be working because on this this modular line, we have 1 digit from 1, 4, and 7, which is the 4, 1 digit from 2, 5, 8, which is the 8, and 1 digit from 3, 6, 9, which is the 9. And for this set of 3, we have one digit from 147, which is the 1. Again, the 8 and 9 satisfy the 2 mod 3 and the 0 mod 3 sets. So that's an example of how modular lines work. We have Nabner lines where on a gold Nabner n line, no 2 digits anywhere on the line may be consecutive with each other. So on this Nabner line, you cannot have consecutive digits at all. But you could have something like, say, 1, 3, 6, and 9. That would be valid, because these 4 digits are not consecutive with any other digit on the line. So that's an example of how Nabner lines work. And finally, or not finally, we still have parity lines, P, where on a red parity line, adjacent cells contain one odd and one even digit. So we could have something like, say, 3 and 6 here, because these 2 digits cannot have to be odd and even as a pair, or adjacent digits. And finally, we have white Kropke dots, where digits separated by a white dot are consecutive, and not all dots are necessarily given. So, for example, if this were, say, a 6, this would have to be a 5 or a 7 here to be consecutive with a 6 because there's a white dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. In box 1, we have 9 unique digits. Excuse me. And these 4 must be consecutive. So these 3 digits, so for every box that has an arrow in it, which are all the boxes 1, 3, 5, 7, and 9, we have 3 digits adding up to another digit. So that means the singular digit must be 6, 7, 8, or 9, because the minimum of 3 unique digits adding up to another digit is 1, 2, and 3, which adds up to 6. But if this were 1, 2, 3 adding up to 6, there's no way that this can form a set of 4 consecutive digits. Right? 1, 2, 3, and 6 means you have 4, 5 left, and 7, 8, 9 left. And there's no way to make those consecutive. So this cannot be 1, 2, 3, and 6. Can this be 1, 2, 4, and 7? And the answer is no. Because if we have 1, 2, 4 here, and 7, that leaves us 3 as a separate digit, which can't be consecutive with any other digit in the box. We have 5 and 6, which are consecutive with each other, but not with any other ones. And 8, 9, and those are not consecutive for 4 digits. So 7 doesn't work. What about 8? 8 with 1, 2, and 5 doesn't work. That leaves us 3, 4 as a set that's consecutive. 6 is consecutive. 6 and 7 are consecutive, I should say. And 9, but no set of 4 digits in a row are consecutive. And 1, 3, 4 doesn't work either for the same reason. That leaves you 2, 5, 6, 7, and 9. But that's not a set of 4 consecutive digits. So that means this has to be 9 here. And these are consecutive. They have to be, or these not consecutive. It cannot be 1, 2, 6. That leaves us 3, 4, 5, and 7, 8, which does not form a set of 4 consecutive digits. And we can't have 1, 3, 5, because that leaves us 2, 4, 6, 7, 8, which does not form a set of 4 consecutive digits. Which means this must be 2, 3, 4 here. This must be 5 through 8 here. And this must be a 1, because 1's not consecutive with 5, 6, 7, or 8. 2, 3, or 4 is consecutive with 2, 3, 4, or 5. Also, neither of these digits can be a 9. Because they both see 9 in this column and row. So this has to be 6, 7, or 8, and this is 6, 7, or 8. Well, if you ever have 3 digits that add up to a non-9, you're guaranteed you must have one must be one of those. If there are three unique digits, they have to have one as one of those three digits. So this can't be 1. We are guaranteed a 1 here. This can't be 1, so we're guaranteed a 1 there. So this Nabner line cannot have a 1. Okay. That's going to be interesting. This Nabner line cannot have a 1. So 1 out of every other pair of digits is going to have to be on this line, right? So you could have 1 out of 2 or 3, 1 out of 4 or 5, 1 out of 6 or 7, and 1 out of 7 or 8. If you have 2, that means you must have, well, you don't have to have very many restricted there. Interesting. Anyways, where is 1 on this diagonal then? Because 1 has to be on the arrow, because these arrows sum, the 3 digits on the arrow sum to a non-9 digit. 1 cannot be on this diagonal here. 1 cannot be on this diagonal here, so 1 has to be on this diagonal here for it to be a complete set of digits 1 through 9. Okay. Now this could be 9 here. We don't really know. Entropic lines. Oh, anytime you have 3 unique digits adding up to a singular digit, 2 out of the 3 digits are guaranteed to have to be 3 or lower. And that's just the way that it works, right? To add up to 6, you have 1, 2, or 3. Obviously, that's 3 digits from that are 3 or lower. 7 requires 1, 2, 4. 2 digits that are lower than 3 or 3 or lower are 1 and 2. 8 requires 1, 2, 5 or 1 through 4. Obviously, that's 1 and 3 or 1 and 2, which are the digits that are 3 or lower. And if you had 9, it could be 1, 2, 6, 1 through 5, or 2, 3, 4. Again, requiring 2 digits that are 3 or lower. So, in box 3, since we have an entropic set, we are guaranteed, and they are longer, they are 3 or more that are longer. We know one of those digits must be from the set 1, 2, or 3, right? The low set. Well, if one of them is from 1, 2, or 3, and the arrow has to have a digit from 1, 2, or 3, that means we cannot, first of all, it cannot be 3 lows here, because then that would eliminate all possibilities for the entropic line to have a low. So this cannot be 6. So this has to be 7 or 8 here. Also, this can't be 6 for the same reasoning. If this were 6, this would be 1, 2, and 3 here, which would be problematic. Because then this Nabner line would have to have the digits 4, 5, so 1 out of 4, 5, 1 out of 7, 8, and 1 out of 8, 9. But you need to have 4 digits which are not consecutive. That's not going to work. So this cannot be 6 here. So this is a 7, 8 pair here on the diagonal. Okay. These can't, or yeah, this is the same set as this. So anytime you have a set, anytime you have a line where you have 3 digits that are each from one different set, that means you're going to, the next set of 3 digits, you're going to lose one of those sets. So that means these two must be the same set. And these two must be the same set. Well, we know these two cannot both be low, because we're guaranteed 2 lows to add up to the singular digit here. So this has to be medium or high here. We don't know which. So and these can't be low, this can't be low, because we're guaranteed a low here. 2 lows here, this cannot be low, so this is medium or high. These two are the same set, so we're going to mark this as orange. What else do we have? So this is either 124 or 125 or 134. So this has to be the digits 1, 2, 3, 4, 5. Obviously no 1 there. These digits cannot have a 7 or 8 in them. So these must be 4, 5, 6, or 9 here. Okay. Hmm. So this digit cannot be 7 or 8 here. So, because these are going to be different ones because they are on the same diagonal, therefore there is only one of each 7 or 8 on this diagonal. So this has to be 6 or 9 here. Interesting. So this could be 1, 2, 3. We don't really know. Or it's 9. Well, this alternates between parities. So we have 2 evens and 2 odds here. That means in the rest of the box, we have to have 3 odds and 2 evens. So if this is 6, this has to be 1, 2, 3. And that works. So that would make this odd. If this is 9, it could be 1, 2, 6 here. That would be 2 odds and 2 evens, so this would be odd. If this is 1, 2, 3, 4, that also works because you'd have 2 odds and 2 evens here, and this would be odd. But we cannot have 9 with 1, 3, 5 here because that's 4 odds already, and then plus the 2 more odds in the box would make that 6 odds, so that's not possible. So this is guaranteed to be odd. We are guaranteed a 2 has to be here. So this is either 1, 2, 3, 2, 3, 4, or 1, 2, 6. We don't know. Let's remove this. So this is 1, 3, 5, 7, 9. Okay. Okay. We know. Oh, that's interesting. So none of these digits can be low here on this diagonal. Only one of these can be low here because again we have at least two lows here, and it specifically actually has to be 2 lows. Therefore, 1 low has to be here. That means the remaining 2 lows, 2 of them have to be on this diagonal here, which means because there have to be 2 lows here, and there's 2 lows here, this has to be low. Because if it's not low, that would mean we have 2 lows here, but then this set of 3 unique digits never adds up to... You would have to have 1 low and at least 2 mediums, which is too much to add up to a single digit. So this must be low here. We have another low on this diagonal, and then another low here. So the rest of this box cannot be low. They are medium and high, guaranteed. Obviously, this is going to be the case. So this is 6 through 9. This cannot be 6, because if it were 6, it would have to be 1, 2, and 3 here, which would mean there's only 1 low on this diagonal here, which means we don't have enough lows in column on the diagonal period. Okay. So this is high, not medium. So that means in the rest of box 7, this is one low. These are two lows here. That means the rest cannot be low. So these are high or 5. Or sorry, high or medium. Interesting. 9, where is 9 in box 3? It must be one of those 3 digits. For the Nabner line to work, these cannot be all high and medium, right? Because one of these is going to have to be a low, and it's going to have to be 1 out of 2 or 3. So this must be the low here. So this is 2 or 3. That means this is high here. This is obviously high there. This is medium or high. So one of these is low. We're not sure which. So this has to be, again, 1 through 5, and 1 cannot be here. This is 2 or 3 there. So whichever 2 or 3 here has to be the same 2 or 3 that's along this diagonal, but it could be here. So that's not that helpful. Okay, can this ever be 6? If this is 6, this becomes a 1, 2, 3 triplet. That means this is also a 1, 2, 3 triplet in row 9, which eliminates 1, 2, 3 in the rest of row 9. So this would have to be 4 and 5 adding up together. But that 4 and 5 plus 1 is 10. So this cannot be 1, 2, 3. Therefore, this must be 9 here. So this is guaranteed to be 9. Where is 9 then in box 7? Cannot be here, cannot be on the arrow. It must be one of these 2 digits here. That means 9 has to be one of these 3 digits here. So we're guaranteed this is either 2, 3, 4 or 1, 2, 6. Either way, we're guaranteed a 2 here. And guaranteed a 2 in one of these 4 cells. So where is the 2 in row 7? It must be one of these 3. So 9 is here. Odd and even sets. Hmm. Hmm. Okay. Where is this digit in box 7? If this digit, whatever digit is here, in box 1 cannot be here. So it would have to be one of these 2 digits here. That means none of these can be that digit. Also, this digit cannot be on the arrow. It cannot be on the diagonal. So that means this must be where that other digit is. So this is 7, 8 as a pair. That eliminates 7, 8 in the rest of the row. So the remaining digits in row, this is 9 as a high digit here. That means this cannot be high. It's medium. So these have to be 1 through 6. Obviously no 2 here. This is 4, 5, or 6 there. Hmm. Where is 1 in column 1? It has to be there. Where is 6 in column 3? It must be here. Okay. Where is this 7, 8? Well, obviously it has to be one of these 3. Where is 8 in this diagonal or in this box? It cannot be here because of the 7, 8 pair here. So 8 has to be here. That eliminates 8 from the rest of this column. So 8 has to be one of those two, which means this can't be 8, which means 8 has to be one of these 2 digits there. Okay. Hmm. 1, again, has to be one of these 3 digits there. So if this is high, this would be 9, and this would have to be 7 or 8. If this is medium, obviously 4, 5, 6. Um, So this digit must be consecutive with this. Could be 2, cannot be 1. 1 would have to force 2 there. 3 could force 2 or 4 there. 4 could be 3 or 5. 5 with 4 and 6. 6 with 5 and 7. So those are the possibilities there. So 8 is one of these 2. Where is 8 in column? Well, box 6, it's one of these 4. It's not that helpful. Modular lines. Oh. Because these are the same set and neither can be low, this is a green-red pair here. Okay. Right, because in each modular set, you have one low, one medium, and one high digit. Can this work as 7? I don't think so. So if this was 7, this becomes 1, 2, 4 here. That means this can't be 2, it's 3. That would force this to be 8. But this can't be 4, it's 5 or 6. But the problem is this digit cannot be consecutive with any of the other digits. But we only have 5, 6, or 9 available. 5 or 6 is always going to be consecutive with 5 or 6, and 9 is always going to be consecutive with 8. So that's not going to work in that case. So this cannot be 7, therefore this must be 8, which makes that 7. 8 eliminates 8 there, so that's 7, which makes that 8. Therefore, this must be 1, 2, and 4 here. And obviously it's not 1. That eliminates 4 in the rest of the box. So we know we have a 3 here. 8 and 7 are here. This cannot be 7 or 8. It's 5, 6 as a pair. That eliminates 5, 6 in the rest of the box. So these are both high. This is 5, 6 there. 7 is here, therefore it cannot be consecutive with 6. 1, 2, 5 doesn't work here, because if this is 1, 2, 5, the problem is that we would have 1 out of 3 or 4 on this line. We have 7, we could have 9, but then the 6 is no longer valid here, because 6 cannot be, okay, 6 cannot be on the Nabner line, so therefore this makes this a 6, which means this is medium. That means this can't be medium, this is a 9. 6 is not, it can, or, again, you can, if this is 1, 2, 5, that forces to be 3 and 4, which would be consecutive on the Nabner line, which doesn't work. So this must be 1, 3, 4 here. That eliminates 1, 3, 4 in the rest of the box. So this is 2 and 5, and that Nabner line works. So 5 eliminates 5 there, so it's 6 and 5. We no longer have 5 in row 7. 2 eliminates 2 here. So where is the 2 to add up to 9 here? It must be here. So that's 2. We now have a 1, 3, 4, 6 quadruplet in row 9, which eliminates 1, 3, 4, 6 in the rest of the row. So that means we cannot have 1, 3, 4, 6 here. Where is the 6 going to be in row 9 then? It has to be one of these two, which means this is a 1, 6 pair. That eliminates 1 in the rest of the row. So no 1 there. Where's the 1 in box 7? It must be here. That means 5 can no longer be here. This is consecutive. We have a 2, 3, 4 triplet in column 2, which eliminates 2, 3, 4 in the rest of the column, so this becomes 8, 9. And to be consecutive, it has to be 2, 3 or 3, 4. So this cannot be, this is guaranteed to have a 3 as one of these digits, so this can't be 3 there. It's 4, which makes that 3. That means this must be 2 and 3 to be consecutive. 3 eliminates 3 here. It's 2, 4 as a pair. That eliminates 2, 4 in the rest of the box, so this can't be 2. It's 3, which makes that 2. 2 eliminates 2 there, so it's 4. This can't be 2 or 4. It's 1, which makes that 2. 4 eliminates 4 there, so it's 2 and 4. Remaining digits of column 1, we have 1, 4, and 3. Remaining digits of column 3, we have 5, 6, and 7. Okay, so 2 is here, which means 2 cannot be on this diagonal. So this is guaranteed to have 1 or 3 on this diagonal. So 2 has to be the other digit, 3 or less on this arrow. Okay. 2 eliminates 2 here, so this can't be 1. Can't be 1 and 6 because of the 1, 6 pair in the box. So this becomes a 3, 4 pair here, which eliminates 3 and 4 in the rest of the row. So this is 1, 2, 6 there. 3 and 4 as a pair, eliminate 3 and 4 in the rest of the box. And this can't be 1. So this becomes 5 or 7. 3 or 4 is consecutive with 3, 4, 5 there. This is an 8, so that's a high, which means this must be low and medium here, and then this must be high here, which is a 9. So that's 9. That eliminates 9 in the rest of the box. So this is not high, it's 5 or 6. 6 eliminates 6 here, so this is 5. That means we have to have a 6 remaining in this box. It cannot be here because of 6 in the row, so 6 is there, which makes that a 3. Remaining digits of row 1 are 1, 2, and 4. Remaining digits of the diagonal are 1, 3, and 4 here. So, this can never be 1, 2, 4 to add up to 7 because we have 1, 3, 4 here. So this can't be 7. 1 eliminates 1 here, so that's 6 and 1. 5 eliminates 5 here, so it's 7, and it eliminates 5 there, so this is a 3-4 pair here. This has to be 5 and 8 as a pair there. 3 eliminates 3 there, so that's 4, which makes that 3, which is consecutive with 4. 4 is even, so this can't be even, it's odd, which makes that 5 and 8. Remaining digits of column 8. We have 6 and 9. Remaining digits of column 9. We have 3, 5, and 8. Remaining digits of column 7. We have 1, 2, and 7. No 2 here because of 2 in the row. Remaining digits of row 8. 3, 4, and 8. Remaining digits of row 9. 5, 7, and 9. How are these consecutive? 3 is not consecutive with any of these. 4 and 8 could be consecutive with any of 5, 7, or 9. We have an 8, 9 pair. 4 eliminates 4 in row 6. We have a 1, 3 pair and an 8, 9 pair in row 6. That eliminates 1, 3, 8, and 9 in the rest of the row. So no 3 or 8 here. It's 5. That eliminates 5 in the rest of the row and box. To add up to 8, you have to, or 9, you have to, this has to be 1 through 6. So we have to have 2, 5, and 6 here. There's no 5 here because of 5 in the row. And this can no longer be 3 because 3 and 2 and 4 at minimum add up to 9, but we can't have 4 on this arrow because the 4 is guaranteed here on the diagonal. So this has to be 1. So since this is 1, these can no longer be 1. This is 3, 4 as a pair. So it's 1, 2, 5 or 1, 2, 6 to add up to 9. 1 eliminates 1 or 8 or 9. So this is 3 here, no 3 here. 1 eliminates 1 there, so it's 2 or 6. 1 eliminates 1 there. What digits can be consecutive here? You could have, well, let's do remaining digits. Remaining digits in row 2 are 3, 7, 8, and 9. Remaining digits in row 3 are 7, 8 with 5 and 6. Well, 7, 8, and 9 are not consecutive with any of 1, 2, or 4. So this must be 3 here. That means this is consecutive with 2 or 4. 3 eliminates 3 there, so this is 4, which makes that 3. 4 eliminates 4 there, so that's 2. 2 eliminates 2 there, so it's 6. So this must be 1, 2, and 6 to add up to 9 there. 2 and 6 eliminate 2 and 6 here, so it's 1. 2 eliminates 2 there, so it's 6, which makes that 2. 3, 4 eliminate 3 and 4 here, so it's 8. So no 5 there, because 5 is not consecutive with 8. No 6 or 8 here. Where is 9 in column 5? Cannot be here because 9 in the row. Can't be here because 9 in the box, so 9 has to be here. That eliminates 9 there. No 9 there. These two digits are the same modulo set. And they have to be 5 and 8 left. So this becomes a 5, 8 pair, and this becomes 7. So this becomes a 5, 8 pair. 7 eliminates 7 there, so it's 5. Oops, 5, so this cannot be 5 remaining in the rest of the box. No 3 remaining here. 9 eliminates 9 there. Where is the 9 in box 2? It has to be here. 2 eliminates 2 there, so it's 4. This can't be 2 or 4, it's 1. 8 eliminates 8 here, 8 here. 4 eliminates 4 there, so that's 3, which makes this 4. Okay. 2 eliminates 2 here. 6 eliminates 6 here, so it's 7, which eliminates 7 there, so it's 2. 9 eliminates 9 there, so it's 8 and 9. 9 eliminates 9 there, so it's 6 and 9. 7 eliminates 7 there, so it's 1 and 7. 3 eliminates 3 here, so it's 8 and 3. 7 and 6 eliminate 7 and 6 here, it's 5. 1 eliminates 1 here, so it's 4 and 1. No 5 or 7 there, it's 6. 8 eliminates 8 there, so it's 5, which makes this 8. 5 eliminates 5 here, so it's 7 and 5. No more 6 or 7 there, it's 8. That makes this 7, that's 6, and 7 eliminates 7 there, so that's 8 and 7. And that's the solution. A little bit harder than easy difficulty, but not that much harder, I feel. It was pretty straightforward, I feel. But there were some tricky points in the execution, definitely. I think overall probably still would label this easy difficulty, but it's a little bit harder than easy difficulty, I would say. Not quite challenging level, though. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.